Okay, here's hoping you can hear me pretty well. So this is the remainder of exercise 4E notes. So we'd done example 1 A and B in class, so I'm going to go on with C. So we have graph has the rule y equals a square root of x minus h, passes through the points 3, 6 and 15, 12. Find the values of a and h. So we have two unknowns, a and h, and we have two different coordinates, so we're going to end up with a simultaneous equation situation. So for R3, 6, we've got 6 equals a square root 3 minus h, and I'll call this equation 1. And then we have, for our second one, we have 15, 12, so we get 12 equals a square root 15 minus h. Okay. So we get this situation. So there's a couple different ways you can approach it, and even I fumbled around with this before trying, but quickly I'll call this equation 2. The easiest way to actually do these, instead of rearranging one to get a the subject then substitute into this, is to do one equation divide by the other, because you do one equation divide by the other, the a's cancel out super straight away, which makes it easy because then you just solve for h, and then we can come back later, sub that in and find out what a is. So we are going to do 2 divided by 1 is what we're going to try. Equation 2 divided by equation 1. So we get 12 over 6 equals a square root 15 minus h over a square root 3 minus h, and as I said, we get nice cancel off there. So we are left with 12, we get 2 equals square root 15 minus h on 3 minus h, and from here, okay, you don't try and multiply by make a difference of perfect squares or anything like that. What you do is just multiply both sides by the denominator, so you end up with 2 square root 3 minus h is equal to square root 15 minus h, and what have I done wrong? Oh yes. Sorry, bit of a brain fade there. And just from here, all it is square both sides. Okay, so we'd have 2, 3 minus h squared. How I forgot that, I do not know. So we just square, so we end up with 4, 3 minus h equals 15 minus h. Okay, and then we just continue to solve for h, so we are going to get negative 3h equals 3, so we get h equals negative 3, and then we're going to sub, let's call that 4. Okay, we're going to go 4 back into our original 1, so we get 6 equals a square root 3 minus, losing my mind, minus 1. Okay, so we get 6 equals a square root 4 equals 2a, so a is equal to 3. I knew there was a 3 in the solution. Okay, and then we can substitute in, so therefore our equation is y equals 3 square root x, and here's the thing, this is a minus 1, okay, so we have negative h up here, Okay, minus 1, we're putting a negative 1 in here, so this turns into an x plus 1. So that's how we do that problem. Sorry for the little break. Okay, this one, find the equation of circle whose centre is at negative 1, 2, and which passes through the point 3, negative 3, 5. So let's do a quick little sketch of this to give ourselves a bit of an idea of what's going on. So our centre point is negative 1, 2, so there, and then we have negative 3, 5, so about there, passes through the point. Okay, so we have this circle like that, and there's my centre point right there. Okay? So we end up with this radius here. Okay? And what we can do, we can find it knowing that that's 2 and that's 3 because of our coordinates. Okay? We can find r just using Pythagoras theorem. So we get r squared equals a squared plus b squared equals 3 squared plus 2 squared gives us 9 plus 4 is equal to 16. Okay? And our standard form of an equation for a circle is x minus h squared plus y minus h squared plus r squared. So we just found r squared, and this is an equals. Geez, I'm making a few mistakes today. Equals, so we've got that, and then we have our h and k. Oh my. We have our h and k from our centre point. So our equation is going to be x centre point plus 1 squared, again negative into the negative gives us a positive, plus y minus 2 squared equals 16. And you can also write that as equal to 4 squared if you want. Quick little note here, okay, in this exercise there'll be used the terms touches and passes through. It's important to know the difference. The big one, in this case it doesn't really matter. It touches this point, it passes through this point, we can use it. You have to be careful when it talks about axes, because we have this point here where it's passing through, and then we have that point. Okay, this is a pass through, this one here, and this one is a touching. Okay. So just to be aware of that. Okay, find the equation of circle with centre at 3, 4, which touches the x-axis. So this is nice. Okay. So we can find the centre and roughly sketch it. So that's our hint. So we have x3, y4, there's our centre point. Okay, and it has to touch the x-axis. So if that's the centre point, it's going to be at its bottom down here. So that's really nice, because that gives us our circles. Ooh, ignore that, that's terrible. But it's touching the x-axis just down here. So that means our radius needs to be equal to 4. So r squared equals 4, our h value is -3, our k value is -4. Actually, h is 3, k. Our negatives coming in the equation. We have x minus 3 squared plus y minus 4 squared equals 4 squared. Okay. So those ones are really nice when it just touches. So if it said passes through and it just said pass through the y-axis, it's passing through somewhere over here. You don't, unless you're actually given the coordinates to this point, you can't assume where it is on this y-axis, which will change the radius length. So that's why you have to be really careful of if it's saying touching or passing through. Right, example 3. Find the rule of each of these graphs shown below. So first thing you need to do is identify the type. So what is this type? So this is AY equals root X. And this one, this is a truncus. It's inverted truncus, but we just need to know it's a truncus. So let's start with our general form. Y equals a root X minus H plus K. General form of our square root. We have our starting point, and that gives us our H and K translations. So our H is -1, our K is -1, so we substitute those in. Okay, negative into the negative means we're a plus, so you always got to be careful of that. And this plus and negative turns into a -4. And then we can use this point here, substitute in to find out A. We have one unknown, one coordinate, so we can solve. So using 0, -2, we will get -2 equals a root -4. So we get -2 equals a -4. So A is equal to 2. Okay, so don't forget to write the final equation. Always got to write the final equation form if I ask you to find the equation. Y equals 2 root X plus 1, all under square root, -4. So that's that one. Now truncus. What's the general form of the truncus? Okay, so the truncus is A over X minus H squared, all plus K. So the truncus is with the square, a hyperbola where it has the alternating lines, that's without the square. So same thing, we have our asymptote, so that gives us our H and K values. So our H is 2, our Y is 1, so we can substitute those in. So we get A over X minus 2, all squared, plus 1. Okay, and then we actually have two different coordinate points we can choose from. We can use 0, 0, or we can use 4, 0. Either one should work. I'm just going to use the 4, 0. So using 4, 0, we get 0 equals A on 4 minus 2 squared plus 1. We get 0 equals A on 2 squared plus 1, so we get -1 equals A on 4, so A is going to be equal to -4. So coming back up, we can say therefore Y equals -4 on X minus 2 all plus 1. Okay, and this is good that we got a negative for the A value because this is an inverted truncus. This is an inverted truncus. Okay. So that keeps it all, and that's fine. And that's it for the chapter. Okay. If anyone has any questions, message me or put a notification on the Google Classroom. Thanks and bye.